So we're given a situation in activity 1.13 where we have a function c of r, and what it does is it takes in the total amount of rope in feet and gives the cost in dollars of producing it. So A just asks us to say, okay, well, why don't we interpret c of 2,000 equals 800. Well, this says for 2,000 feet of rope, it's going to cost us $800. B, they want the units on C prime of R. Remember that C, the output was measured in dollars, the input was measured in feet, so this would be dollars per foot. Okay, so that would be the per foot cost of producing this rope. Part C says we know that C of 2,000 equals 800, and like we said, that means for 2,000 feet of rope, it's going to cost $800. And then they tell us that C prime of 2,000 equals 0.35. What that means is it costs us 35 cents per foot to make rope. So they want us to estimate C of 2,100 using this information. Well, we know that we're already spending $800 to produce the first 2,000 feet, and it's costing us 35 cents per foot to create the rope, to make the rope at 2,000 feet produced. So what we're going to do is multiply that 35 cents times the other 100 feet that we're producing. Okay, so we're going to get a total cost of $835 to produce that. Now again, this is an estimate, so I should have put the squiggly equals there. So that's how we can use a derivative to estimate how much it's going to cost to produce the next 100 units if we already know how much it costs to produce the first 2,000. Now in D, we're given three options, and we want to choose which one's most likely. So let's put them all down here and talk through each one, as we don't have enough information to say for sure which one is true, but we can say why we would think one of them is more likely true than the other. And finally, C prime of 2,000 is greater than C prime of 3,000. So case number one, C prime of 2,000 is less than C prime of 3,000. What that means is our cost per foot is larger if we produce 3,000 feet than 2,000 feet. That's probably the least likely of these, because usually the more you produce, the cheaper it will be, and the cheaper the cost per foot will be. But it's possible that maybe there's some restriction that if we produce over a certain amount, there's a surcharge or a surtax. C prime of 2,000 equals C prime of 3,000. This implies that regardless of what's going on, it always costs us a certain amount per foot to create rope. That's probably the one I would choose, because I would expect producing rope to cost the same amount whether I produce 10 feet or 100 feet per foot. So I'm expecting the per foot price to always be the same. Finally, C prime of 2,000 is greater than C prime of 3,000. This could happen because maybe the more we produce, the cheaper our per foot price is. So the cheaper our costs are going up when we produce 3,000 feet than 2,000 feet, because we get a better price on the materials. So each of these could be possible. Again, I think the middle one's most likely, because I would expect the rate that our costs are going up to be constant as far as producing rope. But there's a lot of other factors that could make any one of these true. What's most important for us is that we understand what's going on in each of them. E. Somebody claims that C prime of 5,000 equals negative 0.1. Well, remember what this means. This is negative $0.1 per foot. This means that if we produce 5,000 feet of rope, our costs are going down by 10 cents per foot as we produce more rope. This does not make sense in this context. The more rope we produce, our costs will have to go up. It really doesn't make sense that our costs would start decreasing per foot at a certain amount produced. We would expect our costs to always increase as the amount of rope produced increases.